Hey guys, Mr. Roden here. Welcome to the 4.1 through 4.4 practice test. Now, if you're seeing it, um, this practice test is a test that we just hadn't gotten to yet, and we want you guys to see this before CMAS happens next week. So these concepts you may see on CMAS, and unfortunately, we just haven't gotten to it yet. So what I want you to do is take really good notes today, and I want you to turn these in to your teacher at the end of class or show them to your teacher. Your teacher will let you know what they want you to do with these notes. Now, there's also going to be a secret code in the middle of this video that I'm not going to write down. I'm just going to say it, and I'll tell you where to write it. And so that tells me that you were listening to it, because we're having a lot of problem with kids just clicking through it and writing stuff down. But we want you to hear the instruction and write it down. So this, if you don't write the secret code down for me, you get a 0 on this assignment. So this secret code tells me that you were listening the whole time. And I'm not going to tell you when it's going to be. I'm not going to write it. I'm just going to quickly say it. And that will tell me that you are listening to the whole video if you write down the secret code in the place I say. Okay, so keep listening, because you're going to really need to know when that secret code is to write down. All right, so let's go ahead and do this. Now, this is the 4.4 practice quiz that you have that we handed out to you guys, and we want to go ahead and kind of show you how to do this stuff. Now, the first problem, it's like you're looking at it and you're probably saying, hey, I have no idea, Mr. Roden, what is going on here, right? So what I want to do now is I want to show you how to do this problem, but I got to get my board working. So good. Okay, so the first thing you see is this word domain. So above the word domain, I want you to write X values, okay? Domain is off. There's different ways to think of the X domain. It's kind of like input, but for this problem, these are our X values, okay? Domain is oftentimes a word we use for X values. The range right here, I want you guys to write above the word range, I want you to put Y values. So when we talk about a function, its domains are your X values and your range is your Y values, okay? So those are two new words we're going to talk to you about. Now, if you look over here at these points, well, this point right here, this is the point, I'll just kind of put it in red right here. This is the point -2, 5 right here, -2, 5. This point right here is the point -1, 2. This point right here is the point 1, 1. And this point right here is the point 1, 3. Okay? Now, the first thing they want us to do is list off the domain. So I'm going to put D for domain, and then I'm just going to list off all the different X values. What are they? There's -2 is in my domain, -1 is in my domain, 1 is in my domain, but look, there's another one, so I don't have to repeat it. I can just say -2, -1, and 1. And in my range, let me just make sure. Oh, in my range, by the way, this is not 1, 3. This is 3, 1. My bad. I'm sorry. So that was wrong. So 1 is in, and then also 3. Sorry, I made that point wrong. That's 3, this is the point 3, 1. All right, sorry about that. So now our domain is -2, -1, +1, and 3. Okay? Now, my range is going to be the Y values, okay? So my range is going to be the Y values. So 5 is in my range, 2 is in my range, 1 is in my range, and then 1 again is in the range. So with the range, I see how I have a 1 here and I have a 1 here. Those, I don't have to repeat that. I just have to put one of those. So this one right here stands for both of those ones in my range, because those are my Y values. And I'm done. Okay? All right. So next problem says this. It says, in exercise 2 through 4, use the table that shows the number of pens and notepads that you can buy with $12. Well, the first thing you want to do is you want to say your domain. Well, what is your domain? Well, yeah, domain are the x values. So the x values are 0, 4, and 8. Now, don't worry about discrete and continuous. So I think number 3, I want you to go ahead and just mark out number 3. We're not going to do discrete and continuous in this class. We used to do it, but they don't want us to teach that concept anymore. So I'm going to not cover discrete and continuous. So we're going to skip that one. Now, we want to find an equation of the function in this situation. Now, first of all, if I look at this, it looks like I'm going up here by 4, and I'm going up here and I'm going down here by 2. Okay? So, there's a couple different ways to think of this. So what I have here is whenever I'm going up by the same x value and the y values also go up by the same number, see how these are both going up by -2? Then this is what we call a linear function. And we've talked a lot about linear functions, okay? This is going to be a linear function. Now, with a linear function, we know about linear functions. Those are always in the form y equals mx plus b. Y equals mx plus b. Now, if I look at this chart over here, do I see where the b is? Where the b is? Well, yeah, because the b happens when the x is 0, right? Remember how when we always do our b, it's always 0 comma something? So guys, this 4 right here, that is my b. So I don't have to do any work for the b because I can see at 0, when x is 0, it crosses the y-axis at 4, 0 comma 4. If I was graphing that point right here, 0 comma 4, I'll just go up to this graph up here, 0 comma 4 is right here on the graph, right? That's the y-intercept. So don't worry about these points, but this point right here is represented on a graph right here. It's a y-intercept, okay? So this is your y-intercept from here. But now, remember, I just borrowed that graph really quick. All right, so long story short, our b is equal to 4. Now, remember, when we do a linear function or a linear equation, we have to write the slope. We need to find the slope. So how do we find the slope? Well, there's a couple of different ways to find the slope. You could a couple different ways to find the slope. You could do y2 minus y1 over x2 minus x1. You've done that in the past. Or what you can do is you can look at change in y over change in x. That's another way to think of it, change in y over change in x. So you could plug in numbers for y2 and y1 and x2 and x1. Let's say I want to use these 2 points right here. So my values for y, so instead of, I'll do it down here. So instead of a y2, I could say that is 2 minus a y1, which is 4. So 2 minus 4 over x2, which is 4 minus 0. Well, 2 minus 4 is -2, and 4 minus 0 is 4. And -2 over 4 reduces to -1/2. So that's my slope. My m equals -1/2. Now, I want to show you another way you could do it. If you look at these numbers here, see how we're going up by 4 on my x's? So my change in the x value is 4, and my change in the y value is -2. So I could also remember, I'm going to just kind of write this, m equals change in y over change in x. That's another way you can think of slope. There's a lot of different ways you can think of slope. Well, your change in y is -2 and your change in x is 4. And again, we already know that -2 over 4 reduces to -1/2. So there's another way to look at slope. So now I can write my equation. My linear function is y equals negative 1/2. That's messy, sorry. Let me try that over. Y equals negative 1/2 x plus 4. And that would be my equation right there for number 4. Okay? All right. And then so let me go put this on the line over here. Y equals negative 1/2 x plus 4. That's my linear function right there. Okay. Remember, function and equation are kind of the same thing. Think of function as a rule, a math rule. You can think of it that way. And there are some things that you have to be careful about with your rule, but start to think this function thing, function. All right. Complete an input-output table for the function y equals negative 1.2x plus 4. Okay, well, we can do that. Well, what's the first input? My input is my x value. So the first input is going to be y equals negative 1.2 times my first x value, which is negative 1. That's my first input. And then I'm going to add 4 to that. So all I did is replace the x here with this negative 1 right here. Okay? All right, so now the next thing, so I'm going to do the math. So doing the math over to the side, I have negative 1.2 times negative 1. I know that's going to be a positive number, so I'm not going to put my negatives there because a negative times a negative is a positive. So right now I know my slope. This answer is going to be a positive number because I'm going to add 4 to it. 1 times 1 times 2 is 2, and 1 times 1 is 1. So I get 12, but then I've got to move the decimal 1 here and 1 here. So my first value in this, and then so I have that. So I have 1.2, but then I have to add 4 to that. I have to add 4 to that. So I'm going to add 4.0 to that. So I have 4.0 to that. So when I add that, bring the decimal down, I get a 2. 4 plus 1 is 5. So I get a 5.2 to put in this box right here, 5.2. Okay. Now, I'm going to erase this. You may need another piece of paper if you have all this work and you can't fit it in here. So you might want to ask your teacher for another piece of paper if you have that, just so you don't get too scrunched in, because I'm going to be erasing this. Now, what's the next input? The next input I'm going to put in is the 0. I'm going to put the 0 in right here. You see that 0 right there? So now I'm just going to put that 0 in for x and see what I get. Well, this one's really easy. Any number times 0 is 0. So this is going to be 0 plus 4. And what's 0 plus 4? Well, yeah, you know 0 plus 4. 0 plus 4 is just 4. So we're going to put a 4 right here in that box. All right. So what's my next input? My next input is going to be 1. Okay. So I'm going to put a 1 right here. And negative 1.2 times 1 is negative 1.2. So I have negative 1.2, and I want to add 4 to that. Now, there's a lot of different ways to do this. Your teacher may have taught you differently. If you're struggling with negatives and positives, what I always do is put a negative positive chart. I know my 1.2 is negative and my 4 is positive. When they're on different sides of the chart, I subtract. So now I get 4.0 minus 1.2. And then I just subtract them, and my bigger one is positive. So I know my answer is going to be a positive number because 4 is bigger than 1.2. The positive wins. So I'm going to have to borrow here. This becomes a 3. This becomes a 10. 10 minus 2 is 8, and 3 minus 1 is 2. So I'm coming up with it with the number 2.8. So I'm going to put a 2.8 in this box. Okay. And then my last one is I'm going to put a 2 into this. So you might need another piece of paper just because there's a lot of scratch work to do here. I'm going to put a 2 into this. All right. So here we go. I'm going to put a 2. So now I have negative 1.2 times 2. Well, that's going to be a negative because a negative times a positive equals a negative. Can't forget to do that. So now I'm going to take 1.2 and I'm going to multiply that by 2. Well, 2 times 2 is 4, and 2 times 1 is 2, and then I got to move the decimal one place here. So I get 2.4, but it's negative 2.4, right? because a negative times a positive is a negative, and then I need to add 4 positives to that. If you think about your chart here, you got your negative positive chart, your 2.4 is negative, and your 4 is positive. You subtract, and our answer is still going to be positive because the bigger one is positive here. So if I take 4.0 and I subtract 2.4 to that, I just go ahead and borrow from the 4 and make it a 3. Bring down my decimal. 10 minus 4 is 6, and 3 minus 2 is 1. So I'm coming up with positive 1.6 for this box right here. And I'm done. Now, don't forget, I'm going to give you a secret code. I'm not giving you a secret code now because it's too early in the problems, but I will be giving you a secret code here pretty soon. So don't keep your eyes because I won't write it. Keep your ears open for the secret code. It's going to be amazing. It's going to change your life. Okay, so here we go. We did number 5, and now we're going to go ahead and do number 6. Okay, you are putting wheels on a skateboard. The function y equals 4x represents the number of wheels needed for x number of skateboards. Is 15 in the domain? Well, yes. You could have x. What does x represent? Y equals 4x, where y represents the number of wheels, and x are needed on x skateboards, right? Because there's 4 wheels on every skateboard. So is 15 in the domain? Well, absolutely 15 is in the domain because 15 would be the number of skateboards. So because x represents the number of skateboards. So that's your x value if 15 is in the domain. So we're going to say yes, and that would represent 15 skateboards. And that's what we're going to write because remember, x value is our domain. That's a word that we give our x values now, domain. All right, so we can just say that. So yes, 15 skateboards. That's how we would represent that. All right, the perimeter of a square is a function of its length, s, of a side. Write a function for its perimeter. Okay, is the function linear or nonlinear? Well, let's just make a table here. So if we're going to find a perimeter of a square, right? Well, so we would have P, our perimeter, equals the side of a square. Now, what do we know about all sides of squares? They're all the same, right? And how many sides do we have on a square? Well, we have 4. We have 4 equal sides. So the function we could write is not perimeter equals 4 times s. Okay, 4 times s could be our function. Y equals 4 times the length of the side, because our length of our side, it could be any value. So let's start. So let's say we have P here, and we have, actually we're going to put here, this is our length of our side in our table, and this is our perimeter, right? Okay, well, if we have our side length is 1, then our perimeter would be 4 times 1, which would be 4. See that? If our perimeter was 2, if each side of our square was 2, then it would be 4 times 2, which would be 8. If our side length was 3, then our perimeter would be 12. And if our side length was 4, our perimeter would be 4 times 4, which is 16. So there's a nice little table right there of the function. This we could call this our perimeter of a square function, right? That's a function, a rule that gives us our perimeter of our square. Now, what's it asking for? It's saying, is it linear or nonlinear? Now, here's a hint. If it's linear, the x's and y's, when the x's go up by the same thing, the y's go up by the same thing. So let's take a look over here. If it's linear, then what are these x's going up by each time? Well, they're going up by 1. Now, if it's linear, then the y's are going to go up by the same number also. Well, what's happening here? We're going up by 4 here. We're going up by 4 here. and we're going up by 4 here. This number is always 4. So that's a way you can say linear. It's going up by the same number each time in the y values. When the x goes up by the same number, the y's go up by the same number also. So yes, we're going to say linear. It's linear. Yes, linear, because it goes up by the same thing each time. Okay, sound good? So what we're going to do on 7 over here, we're, actually number 6. Did I read? Yep, skateboard. Yep, got the 7 is we're going to say in 7 our equation was well, I like the p equals 4s was our function, and it is linear. It is definitely linear because it goes up by the same thing each time. Okay, all right, let's take a look at number 8. Use the graph or table to write a linear function. All right, well, let's see here. Well, number 8, this is a lot of the same stuff we've been doing. Where instead of using the word equation, we're just using the word function. Well, first of all, if I notice, one thing is this is a linear function. And here's a way I can see it on a graph. If I just graph this, notice when I do a graph of this, let me see if I can get this to work for me. My line maker tool sometimes is not good. I can make a straight line through all these points. Now, my line maker tool is not very good, so I'm just going to freehand it. But notice that a line goes through all these points. I can get a straight line through all these points. Okay, there's not any curve in the points. The points aren't kind of going up or down. The points are all contained with this red straight line right here, okay? So that's a way I know it's linear. Another way I can see something is linear is when I can put a line through all the points and not have to move my line, or it doesn't curve or anything like that. Okay, so this is definitely a linear equation. So now I want to write the equation. Now, every linear function or equation is in the form y equals mx plus b. And we've done this before. And the nice thing is I can just do this between 2 points. Well, let's see here. It looks like we're counting by 2's on the y-axis and 1's on the x-axis. So let's see here. Look, from here to here looks like I went up 1, and from here to here it looks like I went 1. So this is 2. This is my change in y was 2, and my change in x is 1, 2 also. So my change in x is 2. So it looks like my slope is going to be 2 over 2, which is just 1. So 1x is just x. So my slope is 1. I don't have to write the 1, so it's just going to be 1x or just x. Now, what's my b? Let me erase this here. And so erase this a little bit. Where is the line crossing the y-axis? Well, I'll do it in blue. It's crossing the y-axis here at this blue point, right? My line is going through that blue point. If I line is a little better here. Sorry, it needs to go up a little bit. So where is that point? Well, since I'm counting by 2's on the y-axis, that looks like it's going to cross at 1. So my equation is y equals 1x plus 1. It looks like it's going to be crossing at 1. So there's my linear equation for my function for number 8. Y equals x plus 1. Because I never put the 1 in front of the x, right? Okay, now number 9, I'm going to show you a way to do number 9 that's kind of simple here. Well, the first thing I want to do, remember, when you write a linear equation, you always want to write the equation in y equals mx plus b. You need to find your m and you need to find your b. Now, if you look at this table right here, we can just see where the b is because the b exists right here. It's when x is 0, the y value is your b when x is 0. Well, what is the y value when x is 0? Well, yeah, it's just 0. See, it's 0 right there? Now, you can think of slope. You can do your slope formula, y2 minus y1 over x2 minus x1. You could do that. Or here's a way to do it. You can just think about change in y over change in x. That's another way to think of it. Change in y over the change in x. Okay, so let's see if we can do that. Well, what is the change in the x value? I went from negative 12 to negative 6. Now notice I'm getting bigger. Or you can think about it this way. Here's an easy way. I went from 0 to 6. The change in x is going up by 6 every time. I'm adding 6. I'm getting bigger by 6. Even though I start in the negatives, I start to get bigger. Now, what's happening to the y's? The y's are decreasing by 3 every time. See how we're decreasing by 3 every time? The y's are decreasing by 3 every time. So change in y is going to be -3. Change in x is going to be +6. And when I reduce -3 over 6, I get -1/2. And so there's my slope. So my slope is -1/2. So now I'm ready to write my equation. I'm just going to write it on line 9 right here. Y equals -1/2 x plus 0, right? But we never have to put plus 0. I could put plus 0, but that, remember in math, we always want to be as simple as we possibly can. It's not necessary, so we don't want to write it. Okay? Awesome. So number 10 says that you have the equation y equals -18 minus 2x, represents the number of y eggs left in the carton after cooking x omelets. So graph the function using the domain of 0, 1, 2, 3, and 4. So remember, guys, domain means x values. Nothing else you've learned in this today. Domain means x values. So these are my x values. So now what I'm going to go ahead and do is I'm going to plug these into my graph to this equation right here. This is the equation, or the function. Equation and function I use pretty much as the same word. Like, there's little differences in it, but today we can just kind of think of them as the same. So my function is 18 minus 2x, and my first input is 0. Okay, I didn't make any omelets, so now I just have y equals 18 minus 2 times 0. Well, 2 times 0 is 0, and 18 minus 0 is 0. So I know my first value is going to be 0, comma 18. I'm going to make a little table over here. Over here is a good table. So here's my x values, and here's my y values. Okay. All right, so now on my first one, I used 0 omelets equals how many eggs? Was 18 eggs left, right? Because I haven't made any omelets. All right, the next number I'm going to put in is the number, the next number I'm going to put in is the number 1, right? So I'm going to put a 1 in here. So this is going to equal 18 minus 2 times 1 is 2. And 18 minus 2, well, that's 16. So it's going to be 1, comma 16. All right. Now, what I'm going to do, I'm going to do one more, and then I'm going to see if I can find a pattern. Does that sound good? All right, so let's do number 2. Let's put 2 in there and see what we get. Oh, by the way, your code, I want next to your name, I want you to write math equals fun. I want you to write math equals fun next to your name right now, please. Do that now. Math equals fun right next to your name on this page at the top of your page. Okay, that's your code for today. Excellent. All right, so now we have 18 minus 2 times, well, what do we have to do? We need to put what number are we putting in? We're putting in a 2, right? Okay, so put in a 2 here. Well, 2 times 2 is 4, so 18 minus 4. Well, what's 18 minus 4? 18 minus 4 is 14, so I get 2, comma 14. Now, this is a linear equation, so therefore the x's are changing by, what are they changing by each time? They're changing by 1, so the next one is going to be 3, and the next one is going to be 4 in my table. Now, what are the y values changing by? It looks like they are going up by a constant rate of 2. So I'm going to add 2 more to that and get 18, no, they're going down. My bad, they're going down because we're having less eggs each time, right? So we're going down by 2. So we went 18, 16, 14. Yeah, we went 12, and then we get 10. And then we can go ahead and graph these things pretty easy. So we know we had 18 eggs. We had when we had 0 omelets, and then at 1 omelet we have 16 eggs. This is easy stuff, guys, right? And then at 2 omelets we have 14 eggs. And at 3 omelets, we have 12 eggs. And at 4 omelets, we're going to have 10 eggs. See that? Now, one thing I want to say is you can see that this is a linear function because a line goes through all these points. See how we can make a line through those points? That means this is linear. It's linear. It's a linear function. It's not curved or anything like this. This is also linear here because we can see it's going up by 2 each time. Excuse me, it's going down by 2 each time. Whenever it goes up or down by the same number, x is going up by 1 and y is going down by 2 every single time. It doesn't ever change. You just keep going down by 2. That's another way to think of it as linear. Don't forget to put the code math equals fun at the top of the page. All right, here we go. You are packing candles into a box. You can fit 15 candles in a box. Write a linear function using function notation. Okay, I'll teach you what that is. Okay. Write a linear function using function notation that represents the number of candles in a X boxes. Okay, so I'm going to teach you something. So from now on, another way to think of function notation is y. Instead of writing y, we're going to write f of x. F stands for function of x. So now I'm teaching you what we call, this is called function notation. This is called function notation. So instead of a y, we're going to use the word f of x, okay? And it makes sense, and I'll show you kind of what that's going to look like here in a minute. Okay, so our function is going to be f of x, because instead of a y, we're going to replace it with an f of x. So f of x equals, I like to do it in red here so it contrasts. F of x, so that's my function. Remember, f of x is just equal to y. It's just another way to say y. That you rep 15 candles per box. So it's going to be 15 times x, or 15x, because x is the number of boxes, and you can fit 15 candles per each box, right? So y, yeah. So, okay. So now, how many boxes do you need to pack 75 candles? Okay, so how would we do that? We would say, we know our function f of x is equal to 15x, right? F of x equals 15x. So we want our f of x, our function, we want our function to equal, how many candles? 75, right? So we're going to put 75. We want our function to equal 75, and we know that has to equal 15x. See that? So f of x equals 75 and equals 15x. So what we're going to do now is we're going to solve for x. So we're going to divide 15 on both sides. And I'm going to do the math here. And it's x equals, well, 15 goes into 75 5 times. So x equals 5. So our function here on 11 is, we're going to write f of x is equal to 15x. And b is going to be 5 boxes. Okay. How are we doing with that? Pretty good? Awesome. Okay, let's keep going down here. Now we're on number 12. Number 12. All right, so number 12 says the table shows the table shows Y dollars on car A and B dollars after X years of ownership. Which function represents a linear function? Car A, B, both, neither, or all. Okay, so let's see here. So my X is going up by 1 every single time. You see that? Okay, now let's look at car A. Car A, we go from 24 to 20, right? 24,000 to 20. So this went down by 4,000. That went down by 4,000. And then here, this went down by 4,000. And here, this one goes down by 4,000. So car A is linear. Car A is a linear function. Okay. Now let's see what happens with car B. Well, here we go down by 24 to 12. That's 12,000, which it still could be linear. But now look what happens here. We go from 12,000 to 6,000. Okay. So we went from 12,000 to 6,000. That's a loss of 6,000. And here we go from 6,000 to 3,000. That's a loss of 3,000. Now, I want to ask you a question. are these numbers all the same? Notice how all of these numbers in our linear function, 4,000, 4,000, and 4,000, all of those were linear, the same number. Okay, are all of these numbers the same? Negative 12,000, negative 6,000, and negative 3,000? No, they're not the same. Those numbers, we have a 12,000, we have a 6,000, and we have a 3,000. It's okay that it's negative, but they're not the same number. So car B is nonlinear. That's the first time I think we've ever seen a nonlinear graph in this class. Car B is nonlinear because it doesn't go up by the same, or down, up or down, doesn't matter, by the same thing. So in 12, in there, so we kind of have that in number 12. So 12, car A is linear, car B is nonlinear. Okay. Don't forget the code I told you earlier. It's okay. Make sure you write that code so you get full credit. You get a 0 unless you write the code. All right. So let's take a look at number 13. Is 13 a linear function? Yes. Okay. So I'm going to tell you right now, 13 is nonlinear. And I'm going to tell you why it's nonlinear right now. What makes 13 nonlinear is x is in the denominator. See that? See how x is in the denominator right here? If you ever have x in the denominator, it's nonlinear. Okay? I'm going to tell you two things that make something nonlinear most of the time. Two major times when we're seeing them. X in the denominator, or having x raised to a power like x squared. If you ever have like y equals x squared plus 2, if you ever raise an x to a power other than 1 or just a power, it's nonlinear also. Okay, so that's something to look at on your CMAS. If they give you like y equals x squared and they ask you if it's linear, it's nonlinear. Nonlinear functions have x in the denominator, or you're having like x squared or x to the third or x to the fourth. Those would all be nonlinear functions. So number 13, ladies and gentlemen, is nonlinear. Okay, because it has x in the denominator. X in denominator. Okay, what about number 14? Well, before I can do number 14, what I want to do is let's just set this equal and see if we can write it in slope-intercept form. Okay, so I'm going to bring that down here. So I got y plus 7 equals 2x plus 3y. So let's look at this real quick. I'm thinking how I want to explain this. Well, I'm going to say this. Okay, is there any x's in the denominator? Well, no, there's no x's in the denominator, right? We got y here. What we could do is get all our y's on one side, right? So we could say, here's what we could do. We could write it like this. So let's get all our y's on one side and all our x's on the other, okay? So let's subtract a y from both sides. I think I'll do it this way. So I'm going to subtract one y from both sides. Well, that'll cancel out. So now I get 7 equals 2x plus 3y. Now, the next thing I'm going to do, let me just flip this around because I want to put my y on the left. So I have 3y plus 2x equals 7. All I did is just switch the sides, and that's fine. Now, let's move this x over to the other side by subtracting 2x's from both sides. So now I get 3y equals negative 2x plus 7. Now I'm going to divide everything by 3. I'm putting it in slope-intercept form. Everything by 3. Everything by 3. So I get this kind of ugly equation that is y equals negative 2/3 x plus 7/3. Now that looks really ugly, right? But it's linear, and here's why it's linear. X is in the numerator. It's on top, right? And there's no x to the second power or anything like that. So this is actually a very ugly, very linear equation because x is in the numerator. X is on the other one, x was in the denominator. X is in this one is in the numerator. Okay, so number 14 is linear. 14 is linear because y equals, what was our equation? Negative 2/3 x plus 7/3. Y equals negative 2/3 x plus 7/3. And then x is in the numerator. X is in the numerator, the top. And that's what makes it this word right here is numerator, sorry. That's what makes it linear because x is in the numerator, where the other one, x was in the denominator, which made it nonlinear. Okay, The table's X, Y dollars, X theater tickets. Find the missing Y value that makes a linear function. So what are we going up by here? So we're going up by uh, 2. We're going up by 2 every time, right? So this has to go up by the same thing each time also. So let's see here. Well, I think what we just have to do is take, what could we do here? We could say, okay, what's 78 plus 26, right? Well, that's, let's see, 8 plus 6 is 14, carry the 1. 7, 8, 9, this is 104, right? And then we want halfway, when you add those two up, I'm just going to find halfway in between them. So I'm going to add them up, and then I'm going to divide them by 2. I'm going to take 104 divided by 2. Now, I know 104 divided by 2, you can do the long division, but I think I can do that in my head. That's 52. So this number is halfway in between, and since we know it goes up with the same thing, it has to be halfway in between. So this is going to be 52, because that would make this thing go up by, I don't know, same thing every time, right? And so that's what it would be, 52 right there. Okay, guys, remember to write that code next to your name. I'm not going to tell you what it is. You just have to remember where it was in the video, and have a wonderful day. See you later. Bye.